All right, we're going to go ahead and get started in Chapter 1, Section 1. So a lot of stuff in Chapter 1 is going to be review, and so this should look, a lot of it will look very familiar, some of it maybe not so much. So first stuff we want to do is identify the ordered pair of point A and plot the point -4, -3. So if we take a look at point A, so point A would be located down here in quadrant 4. So to find its address, we always have ordered pairs as x's and y's. So point A would have x coordinate 6 and it would have y coordinate -5. So point A would be located at 6, -5. The next thing we wish to do is plot the point for -3. So we're going to have our x value and we're going to have our y value. So our y is going to be at -4 and our x is going to be at -4 and our y is going to be at -3. So that would give us our point -4 and -3. So just as a reminder, when we're plotting points, it's always x first, y second, and we go to the x value and then the y value and then plot the corresponding point. So the next part is actually for you guys, so go ahead and on that same graph it wants you to do the same thing. So go ahead and identify and plot the following point. So for you guys, go ahead and identify the ordered pair of point B, and then plot the point 6, 7. All right, so for our U-try, we want to identify the ordered pair of point B. So let's see, and we'll make point B purple. So that's up here. And so we're looking for both its x and its y coordinate. So its x value is at -4, and it looks like its y value is at +7. So we would have the ordered pair -4 and 7. And then we wish to plot the point 6, 7. So that tells us that our x is 6. And, oops, I want a pen, not a highlighter. 6 and 7, so that's going to give us our point right here at 6, 7. So when we're plotting points on a Cartesian graph, we go x and then y, and it's like playing Battleship. We find each of them, and then we just go on a straight line until the two meet together to get our points. All right, so the next thing we need is a definition. So a solution to an equation is a value of the variable or variables that makes the equation true. All right, so let's take a look at our next example. So in example 2 says determine if -4, 7 is a solution to the equation y equals 1/2 x squared take away 1. So according to our definition, a solution to an equation is a value of the variable or variables that makes the equation true. Well, in this case, let's go with our x and our y, because our ordered pairs are always x's and y's. So that means our value of x is going to be -4, and our value of y that we want to check is going to be 7. So that means we need to put these into the equation and determine if we get a true statement. So we have 7 is equal to 1/2 times our x value is -4 squared, take away 1. And I'm going to put a question mark over the equal sign because we want to determine if that statement is indeed true. So following our order of operations, we would do our parentheses, then exponents. So -4 squared is 16. And then 1/2 times 16 gives us 8. And 8 minus 1 does indeed equal 7. So that statement, 7 equals 7, is true. So -4, 7 is a solution. So, all right, it's now your turn. So let's go ahead and determine if 5, -3 is a solution to the equation -4x plus 6y is equal to 38. All right, so to resolve this u-try, we just need to once again plug in our values. So our x value is going to be 5 and our y value is going to be -3. So if we evaluate our expression, we have, or our equation, we evaluate the left-hand side, we have -4 times 5 plus 6 times -3. And once again, we want to know, question mark, does that equal 38? So -4 times 5 is -20, plus 6 times 3 is 6 times -3 is -18. And we still want to know, does that equal 38? -20 plus -18 is -38 is equal to +38. And that statement is false. So 5 -3 is not a solution. So this time we ended up with a false statement, and so it was not a solution to the equation. All right, so let's take a look at our next example. So find the intercepts and then graph using this. Actually, I'm getting ahead of myself. I need to give us a little bit of notes first. So, sorry. Finding the X and Y intercepts. All right, so let's draw a picture. And we'll find in mathematics a good picture will help us do many things. So if we just draw a quick sketch of some graph f that looks like this, or f of x, we want to talk about our intercepts. So our x-intercepts are going to be where our graph crosses the x-axis. So in this picture, our graph crosses the horizontal or x-axis 3 times. So we have our x-intercepts what do we notice that all three of these have in common? Well, that when we are on the horizontal axis, that our y value, or the y coordinate, must be 0. And we notice something similar when we cross the y-axis or the vertical axis. So here we have our y-intercept. And on this, we notice that the x value must be 0. So that is the key to finding our intercepts. So to find the x-intercepts, first thing we need to do is, 1, we're going to set y equal to 0. And then 2, we're going to solve for x. And then 3, we write the ordered pair. X, comma, 0, because we chose our y value to be 0, and then we're solving for the corresponding x, which is exactly what we had here on our x-intercepts. The y value had to be 0, so if we choose y to be 0, when we solve the resulting equation, we will get the corresponding x-intercept. Similarly, we're going to do the mirror process for the y-intercept. So this time, instead of setting y equal to 0, we're going to set x equal to 0. And then this time, instead of solving for x, we're going to solve for y. And then 3, we're going to write the ordered pair . 0, comma, y. So these two processes are very, very similar. We set the opposite variable equal to 0 and we solve for it. When we do so, we're going to find the ordered pair that represents the intercepts. All right. So now, after that, we're ready to do our next example. So find the intercepts and then graph using the intercepts if possible. So we have 3y minus 2x is equal to 12. So to find our x-intercept, we set y equal to 0. So that's going to give us 3 times, we make our y 0, minus 2x is equal to 12, and then we need to solve for x. Well, when we're finding the intercepts, if we set something equal to 0, it's really nice because anything times 0 is always equal to 0. So then that leaves us the equation negative 2x is equal to 12. In solving for x, we divide by negative 2, divide by negative 2, and that gives us x is equal to negative 6. So then our ordered pair is going to be negative 6, comma, and we chose y to be 0. So now we go to negative 6 and 0, and we plot our point. And now we rinse and repeat. But this time we're going to set x equal to 0. So we have 3 times y minus 2 times our 0 is still equal to 12. And once again, 0 times anything is going to be 0. And that leaves us with the equation 3y is equal to 12. Divide by 3, divide by 3, and that gives us that y is equal to 4. So then our ordered pair this time is going to be, well, we picked, oh, not blue, we're doing green this time. We picked x to be 0 and solved for y to be 4. So then we go to 0 and up 4, and now we have our 2 points, and we play connect the dots. And that would be the graph of that line using our intercepts. So just as a recap, to graph something using the intercept method, specifically a line, we set x equal to 0 and solve for y to get 1 point, and then we set y equal to 0 and solve for x to get the other point, and that gives us both the x and the y intercepts. All right. So now it's your turn. All right, so let's go ahead and work on our u. So to resolve u try number 3, we're going to choose first x to be 0 to find our y-intercept. So 4 times 0 minus 5y equals 20. And anything times 0 is 0, so that leaves negative 5y equals 20. So we divide by negative 5, divide by negative 5, and we get y is negative 4. So our ordered pair would be 0 and negative 4. And then we set y equal to 0, so we would have 4 times x minus 5 times 0 is equal to 20. And anything times 0 is always 0. So then we divide by 4, and we get x is 5. So we get the ordered pair 5, 0. So 5, 0 is out here, 0 and negative 4 is down here. And we get a nice line that looks something like this. All right. So let's go and take a look at our next example. So example 4 says to graph the following equation. So we're going to talk a lot about quadratics, which is what this is specifically in Chapter 3. So for example 4, what we really want to talk about is using our good friend, our TI-84 graphing device. So I know everybody has maybe used these, maybe not, so I'm going to assume that you have no idea how to use this. So we're going to start from the very beginning. So if we want to graph this equation using our TI graphing calculator, there's a couple of things we're going to want to do. So if we get our calculator and we turn it on, the first thing we want to talk about is if you look at your keys, in the upper left-hand corner, the down diagonal to the right from the secondary function, there is a key with an x, a comma, t, comma, the Greek letter theta, comma, n. So this key right here is going to be the one that we're going to use for our variable whenever we need so this is the button for our variable. So that's our variable. on the TI-84. So we're going to use that button. And if we want to construct a graph, we're going to press our y equals button right here. So we press y equals, and it gives us a menu that looks like this. So if we want to graph y equals, it already has the y inserted for us in the equals, so we're going to start typing. The next thing we have to be careful with is our TI calculator doesn't understand the difference between a negative and subtraction. So our calculator on the right side down here has a divide times, minus, plus, and then enter. The one over here is our subtraction key. If you look below the number 3, you're going to see another button. That's our negative button. If you need to use a negative, we have to use that button. Whereas if we want to subtract, we're going to use this button. So we're going to type in negative parenthesis x minus 3 squared plus 4 exactly as it looks. So we press our negative key, we go parenthesis, and then we're going to use our variable key up here, x minus 3. We close our parentheses, and then we can use the squared key, which is up left from the number 7, or you can use the caret key for the general exponent. I'm going to use the caret, and you press caret, and it pops your cursor up into the exponent, and then you can type a 2. But when you do that, notice my cursor is still in the exponent. So I have to press my right arrow key to move the cursor back down to the base line, and then I press plus 4. And we'll notice that what I have entered into the y equals screen on my TI calculator is exactly what I have here. So I literally just typed that into my calculator. So graphing it on our calculator can be done by now just pressing our graph key, which is in the upmost right-hand part of our keyboard, and it's going to draw a graph. But that's not particularly helpful when you need to graph something on a piece of paper or in MyLabs, right? Because it's on your calculator. So a more useful function for when we're trying to graph something is when we first learned how to graph things, we made tables of values, right? You picked x's and you find the corresponding y's, and then you plot all of them together. So if we press our second key right here, and then the graph key again, we'll notice it actually makes an xy table for our function. So if I scroll around a bit, I'll notice that it has these following values. In fact, it has enough ordered pairs for me to specifically graph this function. So I've got my table of ordered pairs. So the first one that I would need is if I look at the first row, I have x is 0 and y is negative 5. So I go to 0 and down to negative 5. And then I have 1 and 0. And then I have 2 and 3. 3 and 4, and then I go to 4 and 3, 5 and 0, and 6 and negative 5. And then I play connect the dots, and I have my graph. So to have our TI graphing calculator generate a table of ordered pairs, to recap, what we do is we press our y equals key, we type our function in, and then instead of choosing graph, we go second and table to generate a set of ordered pairs. So something else you may not be aware that your graphing calculator does is after we've put in a function for y1, we can evaluate different things. So for instance, we got the ordered pair right here, 2, 3. Well, what that means is if I put the number 2 into the equation, I should get 3 out, right? Well, I can actually do that on my graphing calculator. So I have this put in. If I go back to my home screen, if I press the alpha key and then trace up here, it pulls up a Y menu. You'll see Y1, Y2, Y3, Y4, Y5, Y6, Y7, and so forth. So let's grab Y1, and then if I go parenthesis 2, that means I'm going to put 2 into the function. And what does it give me out? Oh, the corresponding 3, which is exactly the same thing that I would have gotten if I would have evaluated my original equation by hand by putting in these function values. So if I do that, y equals negative parenthesis, if I put in 2, it's going to be 2 minus 3 squared plus 4. So I'm putting that 2 in to the original function. So now if I simplify that, 2 minus 3 is negative 1 squared plus 4. Negative 1 squared is positive 1 plus 4, but then I have a negative 1 plus 4, which gives me 3. Oh. Same thing in all the different ways. So we can actually use our graphing calculator to directly evaluate functions by using alpha and pressing alpha and then trace, and then putting the input in parentheses. All right, so now it is your turn as always. Well, let's go ahead and do you try number 4. All right, so to resolve you try number 4, we're going to get our table of values by putting in our equation. So we type it in, we have our x squared minus 6x plus 2, and then we go second and table. And that generates our table of values for us. So go ahead and plot some of these points. And we're going to scroll down using our arrow keys a little bit, and we'll see that this thing comes back up a little bit. So let's see, we've got negative 1 and 9. We have 0 and 2. 1 and negative 3. Keep plotting our points. So now we are at 3 and negative 7. We're at 4 and negative 6. And 5 and negative 3. And then 6 and 2. And then finally 7, and we're back up to 9. So we would get a parabola that looks something like this. All right, so the next thing we want to talk about is the distance formula. So the distance formula is, well, let's not talk about what it is. Let's figure out where it comes from. Because a lot of times in mathematics, we spend too much time memorizing what things are and not understanding what they are. Because if we know what they are, it makes them easier to use and also easier to remember. So let's take a look at a picture, because pictures are always awesome. So if we want to figure out the distance formula, let's see what we have. So let's say we have 2 points, and we want to find the distance between these 2 points. So I'm going to call this point x1, y1, And I'm going to call this point x2, y2. So I'm looking for the distance between these 2 points. So if I wanted to find them, my goal is, I want to create a triangle. But the problem that we might think we have is, well, if I make a triangle, I don't know what the ordered pair of this point is. But it turns out that I actually do. So on a Cartesian graph, when I move up and down, only the y-coordinate changes and not the x. So if I went straight down from the point x2, y2 to the point down here, then the only thing that would have changed is the y value, not the x value. So this has to have the same x value as the point that was up here, because I only moved up and down. By a similar argument, if I move horizontally only right and left, only the x changes, not the y. So then the y value of this would have to be the same as the y value of this point over here. So now I actually know the ordered pair of these 2 points. So the distance that I'm trying to find would be the length then of the hypotenuse of this triangle, right? And we know that from the Pythagorean theorem that a squared plus b squared is equal to c squared. Well, to figure out c squared, I would need to know the lengths of these 2 sides. And you might be thinking, well, I don't know how to do that. So let's talk about one of our survival skills for algebra. So algebra is really just the arithmetic of unknowns. Algebra will always follow whatever the numbers do. So for instance, if I wanted to know how far is the number 5 from the number 9, what would I do? Well, I would subtract. 9 take away 5 gives me 4. So 9 is 4 units away from 5. Well, I can do the same thing here. If I want to know how long this side is, it's going to be x2 minus x1. And then doing the same thing on the vertical side, if I want to know how big this side is, I would have the distance would be y2 minus y1. So the idea is here, in algebra, if you ever don't know what to do with the variables, just pretend they're numbers for a minute and figure out what you would do if they're numbers. The variables will always follow the pattern that the numbers did, because variables are just numbers we don't know yet. So algebra is the arithmetic of unknowns. Well, if that's the case, then we can call this our A, and we can call this our B, and then by the Pythagorean theorem, we have the following. We know that it is a squared plus b squared equals c squared, but I'm going to write it in the opposite order. I'm going to do the c first. So I have c squared is equal to a squared plus b squared. But we know what all of these things are. So this one, we have c squared is equal to, and our a is x2 minus x1 squared, plus our b, which is y2 minus y1 squared. So then if we solve by taking the square root of both sides of the equation, we get c, which is the distance, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So in the end, this gives us our distance formula. So the distance between the points x1, y1 and x2, y2 is given by the following formula. The distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula. And you might be thinking, well, why did we go through all this stuff with the Pythagorean theorem to come up with the distance formula? Well, we'll see why in the next example. You can absolutely memorize this formula or put it on a note card and use it. That's great. But we'll see we can often solve problems without actually having to use that formula. So let's take a look at example number 5. Dang it, I'm getting ahead of myself again. I've got to do one more thing before we do example number 5. So we need one more formula, which is the midpoint formula. So let's talk about this one. So let's use the same type of reasoning that we were just using to determine the midpoint between two things. So once again, I'm going to have x1, y1, and x2, y2. Well, if I want to find the midpoint, that's going to be the point that divides that line segment in half. Well, how could I find that? Well, let's argue by analogy using a simpler problem. If I asked you, well, what's the number halfway in between 6 and 10? Well, how would we get that? Well, the number halfway between 6 and 10 is 8. But how did we get that? Well, we would add them together. 6 plus 10 is 16. But then we would divide it by 2. 16 divided by 2 is 8. In other words, the number halfway between any two numbers is their average. That's how you find the number halfway in between. So the number halfway between 5 and 10 would be the average of 5 and 10. 5 plus 10 is 15. 15 divided by 2 is 7.5, which is the number halfway in between 5 and 10. So using that same thing, to find our midpoint then, we would have x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So the midpoint between x1, y1 and x2, y2 is x1 plus x2 over 2, comma, y1 plus y2 over 2. All right, now we're ready for the next example. So we want to find the distance between the 2 points and the midpoint of the line segment connecting the 2 points. All right, so we're going to do this 2 different ways. So method 1, we're just going to use the formulas. So to find the distance between the 2 points, we have that the distance is x2 minus x1 squared plus y2 minus y1 squared. So then we would put in all of our values. So our x1 is negative 7. Our x2 is negative 2. Our y1 is 6. And our y2 is negative 6. So if we put all of those into our formula, we get negative 2 minus a minus 7 squared plus our y2, which is a negative 6, minus 6 squared. So then at this point, we can simplify by hand if we wish. And here we have a minus minus, which would be a plus positive. And we would start simplifying. But it's also worth noting, we have a calculator. So in order to help us not come up with 2 plus 2 equals 5, I would recommend just typing it into your calculator. So we do our square root, parenthesis negative 2 minus parenthesis negative 7, close our parentheses, squared, plus negative 6 minus 6 squared. And we press enter, and our calculator should give us back 13. And the one thing we do need to remember when we're doing that is, remember, we have to differentiate between subtraction and the negatives by using the subtraction key on our calculator and the negative key, which is the one that's down below the 3 on our graphing device. So we get 13, and we'll notice if we did this manually, negative 2 plus 7 is negative 5, or positive 5, because it's plus 7. So 5 squared, negative 6 minus 6 is negative 12 squared. And then that would be 25 plus 144, which would then be 25 plus 144 is 169. And the square root of 169 is 13. So indeed, you end up with exactly the same thing. So then, to find the midpoint, our formula for the midpoint says we add up our x and y coordinates and divide by 2. So to do our midpoint, we would have our x1 is negative 7, plus our x2 is negative 2 over 2, comma, our y1 is 6, plus our y2 is negative 6 all over 2. So negative 7 plus negative 2 is negative 9, so that's negative 9 over 2, comma, positive 6 plus negative 6 is 0 over 2. So we would get negative 9 halves, or negative 4.5 and 0. And that would be our midpoint using our formula. All right, so let's solve this a different way. So method 2, we're going to draw a picture. And to aid in our drawing a picture,
I'm sorry. I wasn't done talking.
all right, so for method 2, let's do the same thing, but let's go ahead and draw a graph. So if we were to plot our points, so our first point is negative 7 and 6. So I go to negative 7 and up to 6. And then my next point is negative 2 and negative 6. So to find the distance between the 2 points, I'm actually looking for this. So if I were to just draw that triangle, it would look something like this. Well, what's the length of the base of that triangle? Well, I just counted off the graph. 1, 2, 3, 4, 5. And then what's the height of the triangle? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so then if I know A and B, then it's 5 squared plus 12 squared equals C squared, which is 25 plus 144 equals C squared. So 169 equals C squared. Taking the square root, we get 13 is equal to c. Well, that's the same as the distance. And we'll notice if we come up and look at our formula, we actually ended up with this same thing up to a sign. 5 squared plus 12 squared, which is 25 plus 144, gave us 169, and we got 13. And notice, did I even have to use the distance formula? No. I was able to just solve this by using the Pythagorean Theorem, because we knew where the distance formula came from. Similarly, if I look at these in terms of x's and y's, here my x value is negative 7, and here my x value is negative 2. Well, what's the number halfway between negative 2 and negative 7? Well, that's negative 4.5. And similarly, what's the number halfway between negative 6 and positive 6? Well, that's 0, which is this, which was exactly what we got, negative 4.5 and 0. So we can figure out all of these things by analyzing them directly instead of just resorting to formulas. All the formulas are is somebody did this math on a generic object. All right, so to resolve this, we can use our distance formula. So the distance is going to be x2 minus x1, so 7 minus 3 squared plus negative 3 minus 3 squared. Oh, I'm not doing the right. Yeah, no. So then that gives us square root. 7 minus 3 is 4, so 4 squared. Oh, there we go. Helps if I put the right things in. And then negative 3 minus 1 is negative 4 squared. So then that gives us 16 plus 16, which is the square root of 32. So after we get to this point, MyLabs is going to ask us to enter our solution in two different ways. So one way is going to be a decimal approximation, and make sure you round to the appropriate number of decimal places. So if we do the square root of 32, we end up with this. And let's go ahead and round this to the nearest hundredth. So if we round to 2 decimal places, nearest hundredth, that would be right here. Using the 5 up rule, we look here. So 6 is bigger than 5, so we would round up and we would get 5.66 if we rounded that to the nearest hundredth. The other way it's going to ask for is the exact answer. So the exact answer means we need to simplify the square root of 32. So we need to take out the largest perfect square that is inside of 32. So one way to do this is to just take a list of our perfect squares. So 1, 2, 3, 4, 5, 6. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. And we need to find the largest perfect square that divides into 32. Well, 36 is bigger than 32. So that doesn't divide in, 25 doesn't divide in, but 16 does. So then that means 16 goes into 32 2 times. So that's going to give us that this is the same as 16 times 2, and the square root of 16 is 4. So that's going to give us 4 square roots of 2. And this is our simplified version of the exact answer. So if we grab our graphing calculator, we can double check that if we type in 4 times the square root of 2, we'll see that we get the exact same thing. So this is just like reducing fractions. We can reduce radicals to get an equivalent expression. So this is how we would do it by hand, but since we're looking for the largest perfect square that divides in evenly, we can leverage our technology to help us out. So to get our calculator to help us out with this, what we would do is we press our y equals button, and we take the number that we're trying to simplify, which is 32, and then we divide it by x squared. And we're trying to find that x that is the largest perfect square that divides into 32. So we have 32 divided by x squared, and then we go second table. And we start looking in our table for the largest whole number in our second column. So we get down to x, and then our whole number in our y column is 2. After that, we'll notice that we're not going to get any more whole numbers. And in fact, once the y values get less than 2, you can stop scrolling down in our table. So we notice we have this entry, and where have we seen that before? Well, the x was the perfect square. Well, x squared, or 4 squared, is the 16, and the 4 was the value that came out. So this actually gives us our answer is 4 square roots of 2. So our calculator found that largest perfect square for us by finding where it divided in evenly. So we can have our calculator help us do that as well. So that gives us our exact answer is 4 square roots of 2, and our decimal approximation is 5.66. As I mentioned in my labs, in the homework it's going to ask you for both of these, the exact answer and the decimal approximation. So lastly, to finish up, we need to find the midpoint. So we have our midpoint is going to be 3 plus 7 over 2, comma, and then we get our y values, which are 1 and negative 3. So that's going to be 1 plus negative 3 over 2. So that's 10 over 2. 1 plus negative 3 is negative 2 over 2. So we get 5 and negative 1. So that would be the midpoint between those 2 points. All right, so the next thing we need to talk about are circles. So a circle is the set of all points x comma y that are the same distance from a fixed point, which we are going to call h comma k, which is called the center. The distance from the center to any point on the circle is called the radius. All right, so on our circle, a circle is a set of all points that are the same distance from a fixed point called the center, and the distance from the center to any point on the circle is called the radius. So if we have a circle, based on what we have here, our center of our circle is denoted by the ordered pair h comma k, And then our radius is the distance from any point on the circle to the center. So x comma y. So and we're going to denote our radius with the symbol r. Well, wait a minute. That sounds very much like our distance formula. So the distance between the center and any point is the radius. Well, if we write that out, the distance between 2 points, if I call this point 1 and I call this point 2, then my distance is going to be the square root of x2 minus x1, so x minus h squared plus y minus k squared. But this distance really should be the radius, because that's our distance, right? Well, if we square both sides of this equation, we get r squared is equal to x minus h squared plus y minus k squared. And that is the equation of the circle. So the equation of a circle with center hk and radius r is given by x minus h squared plus y minus k squared is equal to r squared. So the equation for a circle is really just the distance formula wearing a hat and a scarf, right? Because a circle is the set of all points that are the same distance from the center to every other point. So if we put in the center and any point on the circle, the distance between those two had to be the radius. And so we just moved the stuff around in the distance formula a little bit to get our radius and our formula for the equation of a circle. Okay, let's go ahead. And use this to do our next example. All right, so example 6 says the equation of a circle with center, or find the standard equation of the circle having the center -8 and 1 and radius 3/5. Well, if our center is here, this is our h and this is our k. So my h is going to be -8 and my k is going to be 1 and my radius, so my r, is going to be 3/5. So if I put all of those into my equation that I have here, it's going to be x minus h, so minus a -8 squared, plus y minus k, which is 1, squared is equal to r squared, and our r is 3/5 squared. So then that gives us, after we simplify, x plus 8 squared plus y minus 1 squared equals 3/5 squared is 9/25. So, fun fact about our calculator, in case you didn't know, that our calculator has fractions on it as well. So if I wanted to do this arithmetic on my calculator, I would go parenthesis, and if I press my alpha key and then y equals, it's going to pull up a menu that looks like this. If I choose choice number 1, it says ND, that stands for numerator and denominator. Then I would have 3, use my down arrow, 5, right arrow to pop out of the denominator, close that, and square, and then it'll tell me the same thing that I got, 9/25. But the fraction functionality in our calculator will be helpful. So once again, to get fractions on our calculator, we press alpha and then y equals and press enter, and that will insert a fraction bar on our calculator. So once again, alpha y equals, and then choice number 1 gives us our fraction. And you can put any fraction you want in, manipulating it by using the arrow keys to move between the numerator and the denominator. All right, we're running a little low on time, so I'm going to jump to example 7, and we'll combine both of the U tries, just so I can make sure we get through all of them. So the last one, example 7, is we're going to be using that same formula, but it wants us to graph the circle. So in order to do example 7, we're going to use our same formula, and I'm just going to write it above. So we have x minus h squared plus y minus k squared is equal to r squared. So we have to be a little bit careful, because we notice in our formula we have minus signs. So what this tells me is negative h is the same as positive 3, and it tells me that negative k is the same as negative 4. So if negative h is equal to positive 3, h, when I solve for it, I divide both sides by negative 1, gives me h is equal to negative 3. Similarly, using my equation for k, I have negative k is equal to negative 4. And if I divide by negative 1 and divide by negative 1, that gives me k is equal to positive 4. The center is at h comma k, and my h is negative 3 and my k is 4. Lastly, I have r squared is equal to 2. So then that one gives me r squared is equal to 2. So then square root, that tells me that r is equal to the square root of 2, which is about 1.41 if we put it in our calculator. So then if we wanted to graph our circle, we would go to our center, which is at negative 3 and positive 4. Yeah, I thought so. I clipped something off the end of that, right? This number is supposed to be 25, right? Yeah, I was like, I didn't think I did irrational ones. So I clipped the 5 off when I did the example. So r squared really should have been 25, which makes it a lot nicer. So when we take our square root, we get r is equal to 5, which will make a lot nicer thing. So now we plot our center, which is at negative 3 and 4, and then our radius is 5. So I go out 5 units, 1, 2, 3, 4, 5 from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And then I draw a circle. All right, that's kind of terrible, but that's our circle. So just to recap on what we ended up with, the key thing we have to be careful with is those minus signs in the formula, right? So the minus signs in the formula tell us what the opposite of h is and the opposite of k is. So it's a real common error to assume h is positive 3 and k is negative 4, but it's actually the opposites of each of those.